Hi, welcome to video 10.4b part 1, more on changing rectangular equations to polar equations, and also changing polar equations to rectangular equations.
Graphs. Okay, in exercises 27 through 36, they want you to convert the rectangular equation. So these aren't coordinates anymore, it's actually an equation. It's rectangular because it's in x and y, and they want you to convert it to polar form and then sketch the graph. Now honestly, most of these I would sketch the graph while it's in rectangular form because you'll recognize it better. So as far as sketching the graph goes, if you isolate y, you get 4 over x. It's just a rectangular hyperbola in the first and third quadrants. Okay, but they want it in polar form. So remember, x is r cos theta, y is r sine theta, and that's equal to 4. And then it's just prettying it up. That's r squared times cos theta times sine theta times equals 4. If you were fancy, but this is fine. I mean, you should definitely isolate the r squared because we typically give it as r equals, which you could say, by the way, and I did do that down here, r equals plus or minus the square root of. Okay? Now, if you're observant and you know that the sine of 2 theta is 2 sine theta cos theta, then if I divide both sides by 2, I have sine theta cos theta is a half sine 2 theta. So what happens is I have r squared times a half sine 2 theta equals 4. And that gives me r squared equals 8 divided by sine 2 theta, which would be r squared equals 8 times cosecant of 2 theta. So that would be one way of writing it. Or I could just divide by cosine theta, sine theta, leave that. But of course 1 over cosine is secant. 1 over cosine is secant, 1 over sine is cosecant. So you could leave it like that. Or you could get rid of the square with the plus or minus. I mean, there's many options, okay? Same idea here. We're given a rectangular equation. We want to put it in polar form. Now, hopefully you'll recognize x squared plus y squared directly as being r squared minus 9 times, now x squared minus y squared, we're going to have to go back to x is r cos theta, y is r sine theta. So basically after that we're prettying it up, square each one, factor out the r squared. If you're observant, you'll remember that cos squared minus sine squared is the cosine of a double angle. Factor out the r squared. And now, of course, it's equal to 0, which means either r squared is 0, which means r is 0, which is, by the way, the pole, the origin, which we now call the pole, or r squared minus 9 cosine 2 theta is 0, which means r squared is 9 cosine 2 theta. So, which means r is plus or minus 3 square root of cosine 2 theta is another way of writing it. So either one of these would be fine. I would look at the back of the book and see whether they have r squared equals or r equals. And we'll look at this polar graph later. It's a landscape. Now we're going to go the reverse, 37 to 46. Now they're going to give you a polar equation and you're going to convert it to rectangular form. Here I would actually convert it to rectangular form and then graph, although in some cases it's easier to graph than in polar form. So r equals negative 2. If I square both sides, is r squared equals 4. And of course we know that r squared is equal to x squared plus y squared by the Pythagorean theorem. Okay? So again, here's all the theorems, the relationships we know between x, y, r, and theta. R squared is x squared plus y squared, so r is plus or minus the square root of x squared plus y squared. X is r cos theta, y is r sine theta, and tan theta is y over x. So, although yes, you recognize this very easily as a circle center origin radius 2, this is way easier. These are all the points that are negative 2 away from the origin. So negative 2 whatever degrees, negative 2 whatever degrees. It's the same equation as r equals 2. R equals 5 cosine theta. They want you to change it, remember, into rectangular. So it's going to be tricky because remember, x is r cos theta. I need r cos theta, and all I have here is cos theta. So I'm actually going to multiply both sides by r, which will give me r squared on the left and 5 r cos theta on the right, which of course will work out very nicely because r squared is x squared plus y squared, and of course r cos theta is x. So there's your equation in rectangular form. Now you know that as a circle. You know that if you really wanted to figure it out, you'd bring the 5x over and then you'd complete the two squares and add the same thing, blah, blah, blah. And you'd end up with a circle with a center at 5/2, 2, and a radius of, as you can see over here, a radius of 5/2. So there's our graph right now. As we will see, it's actually easier to graph it directly from here to here and know that this is a circle, and we'll talk about that it's symmetric with respect to the horizontal axis. And both the center and the domain are at half this constant. So the center is at 5/2, in the domain, and the radius is also 5/2. Theta equals 5 pi over 6 is a very interesting one. You would not think that you'd get what you would get. So of course what I'm going to do here is I have to take the tan of each side because the only relationship I have is tan theta equals y over x. So I take the tan of each side. Of course the tan of 5 pi over 6 turns out to be negative 1 over root 3. Tan of theta is y over x, and then I isolate y. It actually is a line, and it is a line through the pole. And if you think about it, what happens if I made a table, and remember I'm plugging in things for theta, well the thing is my theta is always 5 pi over 6 no matter what my r is. So this is a line through the pole, and it makes an angle of 5 pi over 6 with the positive polar axis. Okay? And if you plotted all these points, there's 0, 5 pi over 6. If you went 1, 5 pi over 6, you'd be here. If you went 2, 5 pi over 6, you'd be here. If you went negative 2, 5 pi over 6, you'd be here. All of your points would fall on that same line. R equals 2 cosecant theta. Well, we don't have a formula with cosecant. But what is cosecant? It is 1 over sine. Do a cross product, and of course r sine theta is y. Now here's one where the rectangular version is certainly a much easier version of horizontal line than r equals 2 cosecant theta, but it is a horizontal line. Okay, now we're going to get into line mesons. I know I have a lot on this page, okay? So before we go any further, in rectangular, the origin is called 0, 0. That's the point x, y. In polar, that same point is called the pole. And the coordinates, of course, are r theta. And if it's the pole, it's because you never moved away from the pole, so your radius is 0. It doesn't matter what the angle is. Now, we're going to be making tables for these line mesons, okay? And the ordered pairs are in the order r comma theta. So I want you to leave it as r comma theta, but we're not plugging in r's and finding thetas. We're plugging in thetas and finding r's because they give us r is a function of theta. Hey, sorry. Okay. So we're going to be plugging in thetas and getting the r's that go with them. So here's just an example. I think this is the one I used. Is it? Yes. Yeah. Okay. So if you have r equals 2 plus cosine theta, if you replace theta by 0 radians, the cosine of 0 is 1, 2 plus 1 is 3. Now you'll notice I'm using 0, pi over 2 pi, and 3 pi over 2. Basically that means I'm going to get my intercepts. If I plug in pi over 2, cosine of pi over 2 is 0. 0 plus 2 is 2. If I plug in pi, hopefully that's our last interruption. Anyways, so etc., etc., etc. Now if I graph these points, there's the point 3, 0, the point 2 to the right, and then pi over 2 in the positive direction, the point 1 comma pi, which brings us over here, and the point 2 comma 3 pi over 2, which brings us over here. The pole, which did not show up here, because remember the pole would have to have the r equals to 0. You'd have to check that as a separate thing. What you do is replace the r by 0 and solve for theta. So if I take this equation, replace the r by 0, I get cosine theta equals negative 2, which of course is impossible. If you thought to yourself, oh, you know what, let me just change it into rectangular form, good luck with that. You'd have to multiply both sides by r. You get x squared plus y squared equals 2 times plus or minus the square root of x squared plus y squared plus x. Yeah, good luck graphing that.